Hello. In this video, we will see how to solve some questions, some problems on the AP Mechanics course, and specifically we'll try to apply Newton's laws and friction in order to find final velocity, and also try to work with the concepts of work and the law of conservation of energy. Let's start right through with our first problem. What we see on the diagram is a block that it is moving on a surface, and if we read the question, we see that we have a block of 1 kg that is moving to the right with an initial speed and a force on another object, on another slab that initially is at rest. Now the coefficient of friction between the block and the slab is 0.3, so probably the block will be slowing down, and there is no friction between the slab and the horizontal surface. So on the dots below we need to represent, actually here there are no dots, we will draw the dots ourselves. On the dots below we need to represent the slab and the block. We need to draw forces that represent the forces acting on the block sides and as the block slides on the slab. So basically we need to draw the forces on the block and on the slab. Let's start with the block and the forces that act on it on the block. Now, since we are on planet Earth, there will be a force of gravity and there will be a normal force. However, since there is friction between the block and the surface of the slab, it means that there will be an opposite force as the object is moving to the right, so there will be a frictional force to the left, and since the object is moving, we can say that this friction is kinetic friction. And let's talk about the slab. Again, this slab is on planet Earth, so there will be a force of gravity on it, and actually a greater force of gravity since the mass is greater, and a normal force also from whatever surface is below the slab. So force normal of the surface below the slab to the slab. Let's try to make it a little bit more horizontal, somehow like this. Now, as you probably see, the normal force and the force of gravity in this case, they're not equal. And the reason why they're not equal, and actually I think I make a mistake here, like the normal force will be greater than the force of gravity. But the reason why the two forces are not equal is because there is a push from the block on the slab. So there is one more force from the block to the slab. In reality, this is the reaction of the normal force from the slab to the block. And now, since there was a friction from the surface of the slab to the block, this force will have an equal and opposite reaction, so there will be a force of friction from the block to the slab. So this is the free body diagram for both objects. We can continue to calculate the net force acting on the slab. Now the net force in reality, it is the force of friction. So we will work for the force of friction on the block, despite the fact that he's talking about the force of friction of the slab. So for the block, the force of friction is equal to mu multiplied by the normal. This normal is mass times g, so 1 times 9.8, it is 9.8 Newton. So it is 0.3 times 9.8, so this is 2.94 if I'm not mistaken Newton. Now, we should say that the F net on the slab, it is equal to the kinetic friction, and this kinetic friction is equal to the force from the kinetic friction from the slab to the block, so it is 2.94 Newton. Then it is mentioned that the block reaches the right end of the slab, so the block is moving for some distance that I think that it is not given, and both the block and the slab attain identical speeds, and we're going to find this speed. Now, a little bit careful. Okay, since the block is moving to the right, probably it is slowing down, so I don't know what speed we're going to find, but most likely it will be a value that will be less than 2 meters per second. However, since the block applies a force on the slab, then the slab will also move to the right. So the slab probably is at rest at the beginning and it starts moving to the right, and it is mentioned that the two objects will come to the same speed. So we can say that we will try to find the acceleration for the block, and then we will try to find the acceleration for the slab. Now, for the block, there is a deceleration because of the force of friction, so the F net, it is equal mass times A. There is only friction that we calculated 2.94, and actually it tracks to the opposite direction, so it has to be negative. The mass is 1, and from this we'll find that the acceleration is minus 2.94 meters per second squared, because it is slowing down. In a similar way for the slab, we say that the F net is equal mass times acceleration. Again, the only force is the force of friction to the right, so it is 2.94 again. The mass is a little bit greater, it is 4 kgs multiplied by the acceleration, and if we divide by 4, this will be around 0.74 meters per second squared. Let me just confirm my calculation. 2.94 divided by 4, yes, 0.735 meters per second squared. So we have two different accelerations. Now, we need to find the final speed of the two objects. We don't know what is this final speed, and we don't know after how long this happens, but we know that the V final is equal to V initial plus AT, and for both objects, V final is equal to V initial plus AT, but we know that this V final is identical. So for the first object, the V final is equal to V initial, that it is 0, minus 2.94 times T, and for the second object, the V final is equal to V initial, which again it is 0, or let me just, I think we made a mistake somewhere, that the initial speed of the block was not 0, the initial speed of the block was 2. So the V final is equal to minus 2.94 times T, and the V final was 0 for the slab, sorry, the V initial is 0 for the slab, plus acceleration that it is 0.74 multiplied by T. And now let me explain how I realized that I made a mistake before. Now, had I had 0 minus 2.94 and the two speeds were identical, I would say that 2.9t is equal to 0.7t, which is not possible. So I realized that this is a mistake, and we remember that the initial speed of the block was 2 meters per second. But now we know that these two speeds are identical, so we can say that this part is equal to that part. So 2 minus 2.94t, it is equal to 0.74t. So 2 is equal 2.94 plus 0.74, it is 3.68 t, and if we divide 2 over 3.68, the result is 0.54 seconds. So the time is equal to 0.54 seconds. However, this is not our final answer. The question is not about finding the time. The question is about finding the velocity. So we'll go to this law and say that the final velocity is 0.74 times 0.54, and from this we bring approximately velocity final is equal to 0.4 meters per second. Now I think that we have one more question in this problem to calculate the distance that the slab has traveled until it reaches the V final. So for the slab, we can say that since we need to find the distance, we can use the third law for motion with acceleration. V final squared is equal to V initial squared plus 2a delta x. The V final we found is 0.4. The initial speed was 0, so 2 times 0.74 times delta x. And if we do 0.4 to the power of 2 divided by 2 times 0.74, I believe we'll find that the distance is approximately 0.1 meters. Let me just verify my calculations. 0.4 to the power of 2 divided by 2 and then divided by 0.4, yes, 0.1 meters. Or maybe we can use the second law. Since we know the time, we could have used delta x is equal v initial t plus 1 over 2 at squared. We would find the same answer. And we go to the second question for today, where what we see on the diagram is a spring, an object that it is attached to the spring through a rope and through a pulley. So probably the spring will stretch and the object will start sliding down on an inclined plane. Now we know the mass of the block, we know that there is no friction, and we know the value of the angle, and we know the spring constant. And we know that the block is released from rest, so the velocity initial is equal to 0, and the spring at that position is unstretched. So probably because of gravity, the spring will stretch and probably will perform an oscillation or a simple harmonic motion on the surface of the inclined plane. Now we need to draw the forces that act on the block. We start with the force of gravity. There will be normal force from the surface of the inclined plane, and there is a force of tension. Now in reality this tension comes from the spring force, so either you will say force of tension or maybe you can say force by the spring. So this is the free body diagram. Again, on the free body diagram we draw the forces, not their components. Now the question is, what is the speed of the block when it has moved 15 meters down the incline? Now there are a few ways that we can work here, but let me explain why we cannot work with F net is equal mass times acceleration. Now the total force acting on the object is the force by the spring, which is the force of tension, and the component x of the force of gravity, which is mass times c times cosine of the angle. So the F net is Fgx minus the force by the spring is equal to mass times acceleration. Now, unfortunately, because the force of the spring is not a constant force, it means that we do not have a constant acceleration as the block is sliding down. So we cannot use the laws of motion with constant acceleration because the acceleration is not constant. So we can use either the energy or the work. Now, since we have conservative forces, we can use the law of conservation of mechanical energy, but I will try to solve this with the work energy theorem, which is that the work net is equal kinetic energy final minus kinetic energy initial. Now, there are two forces that act on the block. There is the work by the force of gravity and the work by the spring force. Now, the force of gravity is on the same direction with the motion, the tension force is on the opposite direction with the motion, so okay, we can add the values of these two works, but in reality, one work will be positive and the other work will be negative. So I can say the value of the force of the work by the force of gravity minus the value of the work by the spring force is equal to the kinetic energy final, and the kinetic energy initial was 0. So we need to spend a little bit of time to find the work by the force of gravity, which is the work by force of gravity x plus the work by the force of gravity y, but the work by the force of gravity y is 0 because the force of gravity y acts on 90 degrees with the inclined plane. So we have mass times g times cosine of theta multiplied by the distance. Now the mass is 5, the g I will consider it 10 multiplied by cosine of 42 multiplied by the distance that it is 0.15 meters. So this is the value, so 50 times cosine 42 multiplied by 0.15. And the work by the spring force, we remember that it is half k delta x squared. So it is half k is 150 and the delta x 0.15 to the power of 2. But again, because this acts on the opposite direction to the motion, the value should be negative. So minus 1 over 2 times 150 times 0.15 to the power of 2. And this is equal to the kinetic energy final, which is 1 over 2 mass times velocity final squared. So from this equation, the only one known variable is the V final, and with calculations, with the help of our calculator, we will find that the velocity final is approximately 1.14 meters per second. Now, in part C, the question mentions that the block continues to move down until it comes to rest. And the question is, how far does the block stretch? Probably we can do exactly the same method. So eventually the work net is equal kinetic energy final minus kinetic energy initial, but in this case both the kinetic energy final and the kinetic energy initial are 0, so the object starts from rest and it comes to rest momentarily. Again, the work by gravity, it should be mass times g times cosine theta multiplied by the distance, but now we don't know the value of this distance. And the work by the spring, it is 1 over 2 k x squared, but again we don't know this delta x. So we know most of these values, so 5 times 10 times cosine of 42 multiplied by the unknown distance. I can take the 1 over 2 to the other side. 1 over 2 times 150 times the delta x to the power of 2 is unknown. 1 delta x with 1 delta x cancels. And if we solve for this delta x, we'll find that the delta x is equal to 0.44 meters. So this is the distance that the block travels down, and it comes to rest. So actually this is the lowest point on the inclined plane. And at that point, we need to find the acceleration. Now, obviously, in order to find the acceleration, we'll use F net divided by the mass. However, at that point, we have this. Actually, sorry, we have this. We have the spring on the top of the inclined plane and a rope on the object. So here is the spring that it is stretched. It applies a tension on the object, and this tension is to this direction, and there is the component of gravity that it is mass times g times cosine of the angle. Now, the force by the spring, it is k times delta x, so it is the k, it is given 150, and the delta x on this lowest point, we found it 0.44. So the acceleration is F net, so it is mass g times cosine. Actually, probably the acceleration at the lowest point will be backwards towards the top of the inclined plane, towards the spring. And actually we know the force of gravity, which is mass times g. So the mass somewhere was given 5 times 10 times cosine of 42. So from this we say that the one force is 66 Newton, the other force, it is for sure less than 50, so 66 minus 5 times 10 times cosine of 42 divided by the mass that it is 5, and from this the result will be 6.6 meter per second squared upwards on the inclined plane. And for part D, the question mentions that the experiment is repeated on an inclined plane with friction. The lowest position is 0.25 meters on the inclined plane, and we need to find what is the coefficient of friction. Now we can use a very similar method. We would say that the work net is equal kinetic energy final minus kinetic energy initial, with both the kinetic energy final and the kinetic energy initial is 0, since we start from rest and we come to rest. But in this case there are more forces on the object. There is the spring force, there is the force of gravity, and there is also force of friction, work by force of kinetic friction. All of these works together will be 0. However, we said that the gravity is the one that moves the object, so it has positive work. The force of the spring acts to the opposite direction, and obviously the force by friction acts to the opposite direction. Now, the work by the force of gravity, it is again work by force of gravity x plus work by force of gravity y. The work by the force of gravity y is 0 because the force of gravity y acts on 90 degrees with the inclined plane, and it is force of gravity x times the unknown distance. The force of gravity x is mass times g times cosine of the angle times the unknown distance. Now, the work by the spring force, we say that it is half kx squared, or half times 150 times the unknown distance to the power of 2. And the work by the friction, it is friction times distance. I don't need to multiply by the cosine of 180 because I already said that this has a negative value. Now the friction is mu that we know times the F normal that we don't know, multiplied by the unknown distance. The mu, actually we need to find it, and I thought that the distance was unknown, but I made a mistake. The distance is 0.25, so let me add it in the terms. So multiply by 0.25, multiply by 0.25 to the power of 2. Now, the normal force, it is equal to the force of gravity y, which is mass times g times sine of the angle, and the delta x is 0.25. So we'll place this in our terms. So we have minus work by the spring, so minus 1 over 2 times 150 times 0.25 to the power of 2. Work by the force of gravity, so it is mass times g times cosine of 42 times the distance, that it is 0.25, minus the work by the force of gravity, which is mu times mass times g times sine of 42 times the distance, that it is 0.25. All of them should be 0. And give me a moment to add all of these in the calculator. Now, what I find is that the mu is 0.385 approximately, and the mu, the coefficient of friction, has no units. Now feel free to comment if there's any question. Thank you for watching.